Okay, as people are joining in, good afternoon, everyone. Today for our ICICLE seminar series, we have with us Professor Srinivasan Parthasarathi, professor at the Ohio State University in Computer Science and Engineering, and Pranav Manarikar, who is a PhD candidate at the Ohio State University. Their research interests and work broadly in the space of data mining, high performance computing, natural language processing has been featured in leading conferences and journals. Today, they'll talk about AVOIR, AVOIR, which is a first of its kind practical system that can be used for auditing of the deployed black box AI models against various fairness criteria. Thank you again, Professor Srinivasan Parthasarathi and Pranav Manarikar for joining us today. Over to you.
It's an absolute pleasure to be here, Nilima. So could we start sharing the slides, Pranav?
Yeah, go ahead.
I think Pranav and I discussed this, and we took the liberty of changing the title a little bit. So what I'm going to do is, I had a conversation with Nilima and Beth at a workshop at Georgia Tech some time back, where some of my other work or my broader interest in responsible data science, I felt would be good to talk about here as the different AI institutes are thinking about data and AI ethics management. So I'm going to start the talk talking about that, and then I'll pass it on to Pranav, who will present the main ideas behind AVWA, and then I'll come back at the end to close the loop about some of the other things that we're working on in sort of the broad responsible data science, data and AI ethics space. So Pranav, next slide, please. So what I'm going to talk about today is a journey, in some senses, a personal journey at my end that's been going on for about 7 years right now. It all started when I got essentially a cold call from a colleague in the law school who is going to get started. Next slide, please. Who's going to get started working with some of the leading organizations and companies around the world. Many of them Fortune 100 companies, but all the way to startups and things like that. And so what you see on the left is a graphic of a forthcoming book on what I'm going to be talking about. But essentially, this is dealing with data ethics management and its implications for advanced analytics and AI. Dennis Hirsch is our fearless leader, and he's the law school professor who reached out to me a few years ago. But this is joint work with Tim Bartley, who's a sociologist, Arvind Chandrasekaran, who's in the Fisher Business School. Devon Norris was a graduate student in sociology at the time, currently a professor at that school up north. Myself and Piers Turner, who's a philosopher. So very interdisciplinary team. And one of the things we started thinking about when we got the team together was, if you go back to the Greek philosophers who've talked about ethics in general, Plato was the idealist, Aristotle was more of the practical guy, and so defined the practical way to look at some of these things. So one of the things we felt was a sort of hole in the literature was we really didn't know what businesses were doing. I mean, there's ideal, what one morally should do, which is sort of the Plato school of thought. And then there's the other side of it, which is what is happening, what is going on in practice. And there's a real hole there. There's also the other side, which is regulation. But that almost always lags technology, as we've seen in pretty much every walk of human endeavor. So our study objectives here were, and again, what I'm trying to do here, for those of you joining in a little late, is I'm going to try to give you sort of the broad spec space of some of the things we've been looking at before we jump into this new exciting technology we've developed called AVWA. So this study focused on 3 questions. What risks do businesses use of analytics and AI pose for individuals, groups, and this broader society as a whole? why do certain companies, organizations, think tanks go beyond compliance with the law to reduce some of the perceived threats from AI and data analytics? And what exactly are businesses currently doing? And this was, as we said, at the time we started the study around 2017, it was a gap in the literature. There wasn't a lot that we could look to. So we decided to proceed with trying to answer these questions. Next slide, please. So our approach can broadly be thought of as a mixed methods approach, something that's folks in the social sciences are very familiar with, might be new to a lot of us in AI and analytics. The closest thing I can think of from sort of the AI space is the notion of abductive inference, which for those of you who are from Ohio State, Chandra and JJ were some of the leading progenitors of this kind of abductive approach. So it's a grounded theory approach that sort of moves iteratively from data acquisition, observation to theory to more detailed analysis, and then more data acquisition. So it's this iterative process. So how did we go about doing this? So the first thing is we sat down with about 25 different individuals from organizations across the country and across the world. Mostly with C-suite individuals who are in charge of strategy, compliance, and or privacy associated with their companies. And I'll talk a little bit about the range of companies and organizations we talked to in a slide or two. Each interview was led by one individual, and we started with a standard set of questions that we wanted to ask every single person we talked to. But then we also had a panel of interviewees that would be feeding in follow-up questions, depending on some of the answers we got. So each interview was about an hour and a half long with each of these individuals. Combination of in-person and virtual. This predated the pandemic, but most of them were in person. The main interviewer was Dennis, but then some of us, whenever we could, joined and sort of provided additional follow-up questions. And we got, a lot of data, a lot of information through this process. So that in turn turned into a much broader survey. So some of the questions that we fed into the survey was based on what we learned from those interview processes. So again, this is sort of the grounded theory approach, something that at least in computer science, we're not that familiar with. At least I wasn't when I started this study. And these, the survey questions were informed by the detailed interviews, but they started looking at a broader set of things. And we got about 60 of those surveys filled out by another set of organizations outside of the ones that we did the detailed interviews with. And that led to further data acquisition and then more insights. And we sort of continued our analysis through these interdisciplinary focus panels through a webinar series. And I'll have a web link to the webinar series where you can see where we brought in individuals from academia, industry, government. There was a senatorial staff, a bunch of senatorial staff who participated, including a US senator, nonprofits like the Future of Privacy Forum, to discuss and enhance the learnings from these surveys and interviews. So it was a fairly drawn out process, took a couple of years to get all of these together. The focus panels were in 2020. Next slide. So just to give you an idea of the scale and size of organizations that we surveyed, we definitely had quite a few large cap companies, the companies that you see in the press right now. I can't answer specific questions about which companies we surveyed and which we didn't, but we are allowed to present, for example, the scale of these companies. So the top graph talks about the number of employees in these companies. So we go from all the way from smaller startups or medium-sized startups all the way up to the large cap companies. Also, again, the same thing according to revenue. We have a nice distribution of companies we talk to. We've talked to, a lot of the companies that are in the press right now, or have been over the last few years, about their data, AI, and ethics management protocols and things like that. So a lot of them were discussed. Next slide, please. So the first sort of question we were interested in is trying to understand, how much of the organizational attention was being paid to the perceived risks from advanced analytics in AI. So this bar chart, again, I hope it's visible, but the really dark red is receives a great deal of attention from the corporation. The moderate red is, receives some attention, and pink, which is the far bar in each of these, does not receive as much as attention as compared to the others. And so what we're seeing here is, there was a lot of attention that companies were paying. And remember, this was conducted 2017, 2019. So things have changed since then, and I'll talk about that in a second. But really, the companies then, the organizations then, spent a lot of time thinking about discrimination, especially since there were very clear-cut discrimination laws they could or regulations they could adhere to. There's privacy as well. Again, there were some laws that had been brought in play across countries, not just the US, but Europe, as well as some parts of Asia as well. And then, of course, there were concerns about manipulation of data, and to worry about how that could be avoided, how that could be prevented, as well as unwitting or unmitigated errors that may arise. A lot of the companies were concerned about procedural unfairness. So they distinguish this from discrimination in the sense that this is not a protected group or anything like that, but that's just flat out procedural unfairness. And a couple of the individuals we talked to gave us examples like, the no-fly list. And I can speak to a personal example where back in 2005, I happened to take a flight with a student of mine who happened to, be from born in Dubai. And, for the next 5 years, I think I received more than my fair share of extra scrutiny during just because I happened to be with him on that one flight. And so that was something that companies talked about as being important. Transparency, the ability to understand, what goes into a model, what comes out was very important. At the time we discussed this, displacement of workers was not a huge concern, but that's certainly changed over the last few years since we did this survey and analysis. Another example of something that came up but was not, significant was safety. It's all in the news now, as you all know. And of course, the power imbalance, especially when we're thinking of organizations or governments or nation state actors associated with, not being ethical about the management of data and AI. Next slide, please. Now, what's interesting, if you look at the previous slide and this one, is that there was a pretty strong correlation between what was current law and perceived risks. If you flip back between the previous slide and this one, you'll see both discrimination and privacy received a lot of attention, but there was also quite a bit on current law about these things, as well as manipulation and errors. And there wasn't quite as much in terms of displacement of workers and some of the other things like power imbalance and safety. So not surprisingly, organizations tended to naturally pay more attention to risks that are clearly addressed in current law. But some of them, many of them actually, started thinking about what's coming down the road. And this sort of leads to, what I'm going to be talking in the next slide, please, is why do organizations care about these things? Why do we care about fairness? Why do we care about privacy, security? Why do we care about these things? So managing risks is clearly one of them. And so clearly, as the previous slide showed, they were definitely aligned with that. But there were other reasons also as to why many of these companies approach these problems very systematically, and especially to sustain reputation and trust. We've seen this play out both in a positive sense and negative sense with many companies, without taking names. I think most of you are familiar with these. There's also some of the companies and organizations we talked to, they had intrinsic values related to fair trade and things like that. And so that was something culturally they were sort of very much trying to bring to bear in this space. And the other sort of very important thing that came out of this study was that much of the work, especially in the strategy groups, was about anticipating new policy and regulation. The Algorithmic Act in the US, the EU AI Act, were all being sort of forecasted by some of the people who we talked to. And of course, I mean, there's always, how can we maintain our competitive advantage over, some of the other folks that we're competing with in the market who don't do this, and how can this lead to efficient decision making, were some of the other raison d'etres that individuals had shared with us. Next slide, please. So one of the key challenges that almost all of our interviews and surveys came back with was, one of the key challenges with this is, how do you operationalize this? And we are sort of facing this at an institute level, AI institute level. How do we operationalize that whatever we produce is sort of meets ethical criteria? Now, most of the people we talked to at the time basically said, our approach to this was, would grandma approve benchmarking, which is nice, but on the other hand, it is something that is not sustainable, not scalable, and is perhaps not as substantive as one would like. So one of the things that many of them articulated is real need for substantive benchmarks, but also a real need for thinking about this from a management standpoint. As an organizational director, how do we manage these processes without interfering with innovation? I mean, the key is you have to balance these things. So the grandma approved benchmarking on the right is from a ChatGPT subreddit, where you can read it, but the point is that some of these things that were in vogue were very ad hoc and not really structured enough. And then, of course, one of the things that came back to us a lot was, what about the technology to support this kind of management? And we're going to talk more about that aspect in sort of the second part of the talk here. So these were some of the challenges that these surveys and these interviews sort of pointed out to us. Next slide, please. So one of the things that came out, and on retrospect, this wasn't surprising, but everyone seemed to agree that we need to draw substantive lines between ethical and unethical uses of AI and analytics is only the first step. It has to be more than, just drawing the substantive lines. The organization must have a process in place to ensure that it stays within these guardrails. And we're seeing this play out in the US right now, at least, especially in the political space. I think President Biden just had a meeting with some of these leading lights, some of the major companies that are pushing some of these boundaries, at least in the AI space. And so this is certainly something that we heard again and again from some of these folks. Next slide, please. So when we talk to people, and I come from sort of a parallel distributed computing space. They talked about management structures that I could relate to. They talked about, some of the companies that, or organizations we talked to, had a more centralized approach, which is prioritizing speed. This was really favored by sort of the Silicon Valley startup cultures. But the problem with the centralized approach is, if you have one person in charge of ethics for the entire organization, as we know from distributed computing, it doesn't scale, and it's a single point of failure. And that's a problem. And so increasingly, a lot of companies and organizations have started moving, even back then, 2017 to 2019, started moving to this hub spokes model, where you'd have an individual typically, this gave rise to a new position in the C-suite called, the chief ethics officer. So typically, someone in the compliance or in the strategy unit would be nominated and in charge of, ethics, but they would have representatives in each of the silos that particular company was dealing with. So you would have members in each of the silos. So if you think of AI institutes, a number of our AI institutes are organized along thrusts. You'd have someone in charge of the ethics, but you'd also have, people in each of the thrusts who would speak to some of the ethics associated, data ethics or AI ethics associated issues, so that there would be a shared responsibility for policies and procedures. And what this would do is also it would facilitate more deliberate ethics judgments. And that's sort of where people were moving towards. And I think increasingly, if you survey the same set of companies we did right now, we haven't done this, but I would anticipate many of them have moved into this hierarchical or distributed model where you have a hub and spokes model for management structures. But management structures alone is not enough. We need to think about processes. Next slide, please. And one of the things that came out of this, and this was a surprise, especially to some of my colleagues, I really did not have an opinion on this, but a lot of the data ethics function, at least we learned in current approach, tends to be more strategic, tends to be more forward-looking rather than just complying with current law. So it wasn't, oftentimes these ethics functions did not reside in, say, the privacy officer's purview, although in some cases it did. It was more to do with more strategic units within the organizations. And usually with these processes, and we talked about structure in the previous slide, there are two key functions that this process is intended to address. One is spotting and escalating issues via maybe something like checklists, which some of the companies we interviewed said they were doing. But the other is, how do we address these issues? And certainly with the hub and spoke model, building consensus and majority was more of a cultural choice at that time. As I said, when we interviewed these people, they kind of varied across the place. But I think increasingly companies are moving some of these ethic management processes to the strategy unit. Again, related to the quote I have on the top of the slide. There's another thing that I think our study revealed was that there's an increasing move towards holistic approach towards this. Companies' own use of advanced analytics and AI, some of the companies were focused on that, certainly more in the startup realm. But some of the other companies that we surveyed, some of the bigger giants were looking at things in a more systematic or holistic approach. And that's something, in fact, we've talked to a few venture capitalist firms, a lot of them who advise startups have started integrating an ethics-oriented officer on their staff to help some of the startups with some of these things. So again, an increasing move towards a holistic focus is what we're seeing currently in this space. Next slide, please. So we talked to largely folks from the compliance, strategy, legal departments at these companies, but a lot of them did talk about technology and what kind of technology is needed to support ethical data management for data advanced analytics and AI. Across the board, data privacy is viewed sacrosanct. And the de facto standard that we heard from almost all the people we surveyed was the differential privacy rules at some level or the other. Now, clearly, there are some attacks on differential privacy, so you need to keep improving what you can do. But certainly, most of them were not only aware of it, but were actually using it at the time we surveyed them. Many of the folks that we talked about emphasized fairness and transparency. We're going to talk about fairness in the second half of the talk, but basically, how do you use the data and how do you ensure the models you develop are fair with respect to protected groups, with respect to sensitive attributes, and so on. And also in this context, when you bring in sort of regulatory requirements and things like that, there's a clear and pressing need for, explainable models, as well as explaining how the data goes from where the data starts, where it's collected, all the way to how it's used inside these models, especially with some of the GDPR stuff that had come out by the time we were doing this survey. And then finally, a number of them talked about, technology strategies to ensure security and safety, credentials, access controls, and data lakes, the use of virtualization, encryption mechanisms were all discussed. But one thing that came out from this was we really need better mechanisms to audit these things, kind of analogous to tax accountants, and the IRS. We need mechanisms to be able to audit data use and access. We need mechanisms to audit who has access, who should be having access, who has moved the data where, provenance, as well as fairness and safety considerations, which are really becoming more central today. Next slide, please. So to take sort of what I've taken, what I've mentioned here about what we did in these studies, there are four sort of key lessons. The key lessons are what companies told us were managing different types of risks is important. There's a whole set of them at the time. Discrimination, privacy, manipulation, and procedural unfairness were central. Right now, if you look at it, certainly safety and power imbalance and workforce displacement are becoming more central today. Building trust is the primary raison d'etre for why companies try to do this and try to look ahead with ethical AI and data management. Values, competition, regulatory requirements, future regulatory requirements play a role here. One thing we took back was that ethics management structure and process is key. We talk a lot more about this in the book. And it's trending towards the structure is trending towards a hub-spoke model, which facilitates scalability, which facilitates meaningful deliberation on the ethics problems, and yet allows you to be efficient as a company in terms of making sure that you're not, just putting, stoppages on innovation. So it's a nice balance, is what we've heard from a lot of the people that we talk to. And of course, technology solutions are very, very important. And auditing techniques were identified as key. Fairness, privacy, safety, and transparency capabilities were also deemed important by this study. So I'm going to now turn it over to Pranav to talk about some of the technology solutions that we've been developing in the lab here. Pranav, over to you.
All right. Thank you, Professor Srini. So I'll just get us started off. So our goal is to develop certain kinds of auditing tools for machine learning models. And we know that many machine learning models deployed in the real world are only available through black box access, that is, without any knowledge of their internals. To this end, what we are doing is we are building an auditing tool to help estimate the fairness properties of the outputs of such black box models. We will do this at runtime through iteratively refined estimates for decision rates for different groups in the population. Our system for auditing and verifying fairness online through iterative refinement is shortened to AVA. AVA works in the setting of a classification task where given inputs X fed through a model to generate outputs Y, and with sensitive variables S and classifier score S, we want to measure whether the classifier is independent of any sensitive variable that a user is interested in verifying the fairness of. Independence from group membership can be measured through group fairness metrics. Examples of these include demographic parity. Let me see if I can get a pointer here. Demographic parity, which means that there are equal rates of selection for different groups within the population, and equality of opportunity with equal rates for different groups, given that an individual is qualified. And there are many different variations of defining fairness metrics for groups, and we want to account for as many of these as possible within our system. Formally, given a fairness claim psi, such as demographic parity, and a stream of input and output data, xt, yt, we aim to refine estimates of the validity of psi across all time steps while keeping the overall error rate across all estimates under a given probability threshold delta. I would first like to talk about why we are motivated to build this. Professor Srini already touched on these topics in his when he was speaking, but just to reiterate, deployed machine learning models, even those trained with some fairness properties in mind, can have biases since there are several sources of risk at both the training and testing time. Governments and lawmakers across the world are wrestling with finding mechanisms for auditing these models, and examples include AI acts in the EU and the FTC and White House task forces in the US and their recommendations. Specifically, the deployed behavior of a model in terms of the distribution of data may differ from that encountered at training time. In standard statistical modeling, we fix a sample size and then collect samples to reject or fail to reject a null hypothesis related to certain properties that we want to guarantee for our data. In AVWA, we want to make adaptive estimates that control for an overall error rate and guarantee termination in finite steps. Additionally, we want to ensure that we do not waste any collected labels during runtime, as labels tend to be expensive to obtain. However, we cannot peek at the label data to estimate a sample size for a given error rate threshold, as that would amount to p-hacking, as we are looking at the data to understand what thresholds we should set. Finally, there's a potential for optimization of these estimates across different groups within a fairness claim, since we observe a different number of samples for majority and minority classes. At any point, if we make certain estimates for these classes, we would be more confident in our estimates for the majority class, as we've observed more samples for them. There are some existing tools for investigating fairness properties of machine learning models in the industry as well as academia. These include IBM's Fairness 360 framework and work in the program specification and fairness communities. However, these tools have shortcomings. One major issue with commercial tools is that they only support a limited number of predefined metrics. While academic work, such as FP and VF, have tried to tackle this, they're hard to deploy in the real world as they make assumptions about the underlying data distributions. For this reason, they are often evaluated on simulated datasets only. Further, some of these prior works also make assumptions about the machine learning model and cannot be applied to arbitrary black box models. Finally, none of the existing work in academia or industry includes mechanisms for visual diagnosis of failures of fairness specifications. For example, if a gender-related fairness specification is violated by a machine learning model, they don't have any support for diagnostics that indicate why this violation may have occurred. There are three key ideas in AVWA. First, when making estimates for any Bernoulli random variable, for example, one representing the rate of acceptance for a specific group within a population, adaptive inequalities can provide tighter estimates. These can be generated through the idea of adaptive confidence sets. In such a setup, we aim to estimate a sequence of confidence intervals for expectation of X around an empirical mean, E bar T, at time T. Here, epsilon delta T defines the width of this confidence interval at time step T, while ensuring that the overall error rate remains below delta. The specific functional form of the inequality we use is the adaptive Bernoulli estimate corresponding to binary decision variables. Next, inspired by prior work, we enhance the fairness grammars to allow representation of a wide range of group fairness definitions. In practice, this corresponds to implementing inference rules corresponding to each production within the grammar. For example, in this first plot, we see how the sum of the two terms on the top would lead to the plot on the bottom. Similar inference rules can be implemented for other productions, such as multiplication. In functional form, these look something like this. Each of these inference rules describe how to combine the estimates, confidence intervals, thresholds, and potential constraints to compute the corresponding terms for a production rule within the grammar. We show two examples here corresponding to the sum of two estimates and a bound on the estimate. To account for estimation of any term within the grammar, we have to construct similar inference rules for each possible production within the grammar, which gives us a big collection of rules like this. The third key idea involves optimizing by distributing uncertainty. We can optimize the overall uncertainty by distributing it across the different constituent groups within a fairness expression. We illustrate this with an example here. Suppose there is a fairness specification requiring that we ensure that the difference of acceptance rates between two groups in the population is less than 0.2, and the failure probability threshold that we tolerate this is 10%. Suppose additionally that using adaptive estimates and adaptive inequalities, we can make estimates for each individual group with epsilon and delta I. We'll now look at this visually. The purple region in this graph represents the allowed failure probability for each individual term that guarantee an overall rate of 10% failure. That is, delta 1 plus delta 2 is less than 0.1. The brown region here represents the concentrations for each term that ensure that the overall difference in the acceptance rates for the two groups is under 0.2. That is, epsilon 1 plus epsilon 2 is less than 0.2. In all prior work, one assumption was made that the uncertainty can be distributed equally amongst the different groups in the specification, which lie on the line delta 1 equals delta 2. However, we can see that there is no region where all three of these intersect, but AVA, on the other hand, does not make the assumption for equal uncertainty across all groups, and thus can find solutions that lie in the intersection of the brown and purple regions. I'll now move on to the case studies we have, unless there are any questions.
Go ahead, Pranav.
All right. So to summarize the case studies, prior work has provided estimates and guarantees under strong assumptions about the knowledge of the underlying data generating process. In AVWA, we reach these guarantees in fewer steps under more practical assumptions. And we provide formal proofs for this in the paper. Further, since we use an inference-based mechanism, we have the estimates corresponding to the constituent terms in any specification, and we can use these to investigate fairness violations in the specification. We'll next discuss two example case studies where we investigate such violations. First, we took a popular example of fairness, the COMPASS recidivism prediction task. ProPublica, a journalist organization, carried out an investigation that shows that a crime recidivism prediction system that was deployed in Florida was biased against non-Caucasian races. North Point, the creator of the system, claimed that ProPublica used the incorrect definition of fairness, using the output of the model conditioned on its true recidivism value rather than the true value predicted based on the output. We put these claims to the test in AVWA and find, to the best of our knowledge, the first definitive framing of these claims that shows how in expectations, the central blue line here, both the claims hold, that is both ProPublica's claim and North Point's claim hold in expectation, where ProPublica claimed that this line was under the green threshold and North Point claimed that it was above the threshold. However, when we take the confidence sets generated from AVWA, we can see that the ProPublica claim holds with high confidence, that is that the blue region is under the green line, while the one from North Point is not guaranteed. In the real world, we can imagine COMPASS being deployed with AVWA auditing, which would prevent any confusion of fairness definitions and also provide tracking of any guarantees associated with the system, so that any organization, for example, ProPublica, can actually audit the claims made by the creator of the model, such as North Point. Another example we look at is an intersectional one, gender plus race fairness. Here, we take a definition and an example from another popular dataset, which is the adult income dataset. We find that in balancing the probabilities for the two different terms, one corresponding to the gender and one corresponding to the race, the optimized AVWA algorithm can reach guarantees in 10.35% fewer observations than an extension of the previous work, which requires fewer assumptions, VF, within our framework. So that concludes the case studies. I'll hand it back to Professor Srini to summarize the key takeaways and also describe our main directions for future work.
Thank you, Pranav. Next slide, please. So I think Pranav has done an excellent job with describing what Avoir is doing. In terms of some of the key takeaways from sort of the Avoir side of this talk is that, these structure-enabled optimizations, especially with respect to the group fairness grammar and the constituent elements, are kind of critical for efficient optimization, especially with respect to the example he showed, where if you distribute the uncertainty carefully, you can get results, you can converge faster with respect to the guarantees. Adaptive confidence estimates, and here we are building on the shoulders of giants who presented this at Annals of Statistics a couple of years ago. We are leveraging some of these ideas so that Avoir can use it, so that we can work with deployed machine learning models at runtime and adjust for multiple comparisons. And this sort of allows us to monitor models after they've been deployed in the real world. And again, this whole notion of, breaking it down into constituent structures, which enables or facilitates the kind of auditing that Avoir is capable of doing. So that, and we have a demonstration that we can show offline where, you can actually localize failures. I think Pranav briefly touched upon it in one of the case studies that can point to where the failure is occurring and can allow the machine learning developer to fix the problem. Again, Avoir is only a method for auditing. It's not a method to fix the problem. Fixing the problem requires additional steps by the machine learning engineers when they're looking at these kinds of problems. So next slide, please. So what are the implications of this work? So first of all, as I said, Avoir can serve as a mechanism to evaluate audit claims of fairness in machine learning models and keep the creators of these tools accountable. As Pranav pointed out, this is the first, at least I've seen in the literature, where we are able to give a definitive framing on the hotbed debate between ProPublica and Northpoint, for example. It can be deployed in a manner, and the closest analogy I can think of is to the Clean Air Act of 1970 in the US that regulates industrial process effluents in and around factories, not just factories, but other day-to-day activities, including, paintings and things like that, house painting and stuff like that. So fracking and many others. But the idea is that once something is out there, a factory is in place, you have sensors around the factory that monitor, what parts per million these various gases and other things that are harmful are being emanated. And if you exceed whatever the government regulated rate is of these, then you are subject to legal proceedings. And so we are anticipating a similar kind of thing in sort of the AI ML space at the way things are progressing today. And Avoir can certainly serve as a starting point for evaluating some of these. To reiterate, it supports real-time monitoring of fairness of black box ML models. It includes a domain-specific language for flexibly defining fairness metrics of interest, which can vary across different organizations. Not everything is defined based on regulation, as our previous study showed. And it also provides some initial steps towards a visual diagnosis of fairness failures. And most importantly, unlike previous work, it relies on some theory without impractical data distribution assumptions or data generative process assumptions that previous work had required. And so allows this to be much more practical. Next slide, please. Pranav, next slide.
And this is...
Yeah. Okay, so in terms of what we're looking at next, we'd like to be able to generalize the theory that we have so far, and further, even more, reduce the assumption, some of the assumptions we have in place. So independence and identical distribution, we'd like to be able to run AVWA on graph data sets that don't have this IID assumption. We'd like to be able to work with non-stationarity in both the time series as well as spatiotemporal space. And importantly, we'd like to be able to extend this to a distributed setting where you have observers. You can think of AVWA as an observer that is observing traffic, that is observing decisions. And if you have this distributed observer, how exactly are we to do this? We have some initial ideas on, what the underlying theory could look like. We'd like to be able to improve this. The other sort of extension we're very interested and keen to look at is how do we extend this framework to other potentially related ethical considerations, especially safety? So can we use, for example, the DSL to specify guardrails and monitor some of the internal decisions being made by the machine learning agents in sort of an RL setup or something like that? And so that's something we're interested in looking at, and we're talking to some collaborators within AI Edge to see if we can find some solutions for that. Another aspect that Pranav and I are interested in exploring is how do we enhance, the visual diagnostic support. Right now, it is a toolbox that, academics who can use, but how do we get this out there? How do we get it, out there for others to use? And how do we get C-suite folks to buy into some of these ideas? And so in that regard, we are planning some user studies with real-world ML engineers and educators. And if any of you listening would like to play around with it, we'd love to have you and talk to you about some of these efforts that we are trying to explore in this space. Now, this is sort of future work that we're looking at specific to AVWA, but we're also interested in the broader space. And I have other students, including Pranav, who've been looking at sort of fairness and how can we fix fairness issues, especially in sort of the graph or network space. So there's a lot going on in that space. But again, these are sort of future work directions related to auditing of ML technology. Next slide. And I think, so I'm going to leave you with some resources. Next slide. These are a list of some of the resources related to, so the ethics focus panels and webinar series that was run out of the Program on Data and Governance led by Dennis Hirsch. Included, for example, individuals like Chris Coons, the US Senator from Delaware, and his staff, as well as many, many other leading folks from industry, academia, and government. And then the articles are listed here, as well as a forthcoming book that we hope to have published by fall of this year. Next slide. And here are some additional resources about AVWA, the technology that Pranav presented. We have a paper on this coming up, a couple of promotional videos. And at this point, I'm happy to take questions along with Pranav. Next slide.
Thank you, Srini, Pranav, for this excellent presentation. Any questions from the audience?
Srini, DK here. I have a question. So if you want to, I mean, again, I think first of all, you gave a very big overview. A lot of these issues are very pressing. How do we go step by step? I mean, this is the field is so. I mean, it is evolving. There are a lot of issues. For example, from the ICICLE side, if I am thinking how to bring these kind of things into our design developments or our thoughts, how should we proceed?
So yeah, that's a great question, DK. I think if I reflect back on the study we did with Dennis and Arvind and others, one of the key takeaways and one of the challenges that every single one of our interviewees and every single one of our survey respondents had was, we need to figure this out, and we need to figure it out soon, because the typhoon is coming, so to speak, for lack of a better analogy. One of the things that, but at the same time, I think a lot of them talked about, the need to do it in such a way that does not hamper innovation.
Okay.
So I think there's a balance that needs to be struck here. I'd say in terms of structure, I'd say the hierarchical method. As I said, I mean, one of the things that a lot of the AI institutes, if you think about ICICLE, or, well, I don't know enough about ICICLE, but at least AI Edge is organized among thrusts and things like that. You could envision having one individual identified as sort of, I mean, all of the thrusts have thrust leads. And so one of the individuals in each of the thrusts could sort of play the role of a representative of sort of this broader ethics committee, reporting to an individual, maybe the managing director or the director or someone else who's in charge of ethics overall for the institute as large. And that is a by-committee approach for managing these threats. And they are legitimate threats. They are things we need to worry about. And that's one thing I want to make sure I'm clear on. At the same time, you don't want to ask every single ML engineer to write out, you know, a 2-page report on the ethical considerations or designs of every single algorithm they come up with. So, so there needs to be a way to make sure that you're not creating too much busy work. So it needs to be managed. So I don't have a, this is why I think this is a great question. I don't have a concrete answer. I do think the hierarchical approach is the way to go, but how do you minimize the overhead is the key. I think that is going to be critical. Now, with respect to your question and with respect to AVWA, it's actually pretty easy to use, because we don't care about, as long as it's an ML algorithm that's making decisions, we really don't care what the internals are. And this is why companies like this idea, because they don't want to give up their secret sauce. Okay. You know, they have a, fancy new recommendation algorithm or a fancy new prediction algorithm. They don't want to give that away. We can evaluate whether the decisions being made are, fair with respect to a specification that's been coded into AVWA. Now, again, we can do this not just for pure machine learning algorithms. We can do this for human machine teams that are making decisions as well. There's nothing restricting this approach. It's just that when you have an algorithm making decisions about your life, it can do it at a far faster way, and you know this better than most, that we can compute these decisions much quicker, and so you need something to be able to keep up with it. And that's sort of one of the things we're interested in doing, is taking AVWA and making it scalable. Can we run AVWA in sort of a parallel or distributed setting, ideally in an edge space as well? I do want to give Pranav, do you have any further thoughts on this? Question from DK?
No, I think you covered the main ideas pretty well. I think there's different approaches being tested by different individuals, and also regulatory oversight that's coming into the play. So it's a complicated space. So I think your answer was pretty comprehensive.
Spiros, you have a question.
Yeah, I wanted to follow up on basically DK's question about where do we start, and your proposed suggestion, this by committee approach. A unique challenge of, again, entities like, say, ICICLE or AI Edge, right, is their cross-institutional nature, right? That is, we have a structure within the team, but also, we have to basically, in some sense, we also have the ethics framework from Ohio State and other partner institutions, right? So where do you see, in some sense, this basically transitioning to, given that it's not really ICICLE being the one-stop shop, so to speak, about making ethical determinations, right? There needs to be some basically upstream connection, right, to the ethics framework as, say, for example, Ohio State has, and so on. You're muted, Srini.
Yeah, Spiros, you're absolutely correct. And it's ultimately about who is impacted. So, for example, you could look at your specific use cases. If your technology is going to be used by farmers, okay, or if your technology is going to be used by animal conservation folks, well, those are the people you should be worrying about and making sure they're at the table for some of these discussions. Because, you know, use cases are going to drive the people, your user base is going to drive your answer to this question. So there's technology, there's ethics of technology, but there's also ethics with respect to how the technology is being used in the specific silo or domain. The reason why many of the companies, and again, I'm not supposed to name the companies, so I'll try to make sure I don't do that. But some of the really large companies that have their fingerprints all over this space, search companies, big technology companies, their point is that ethics in these different silos means different things for different people. And so it is really, really important. We can't come up with a, you know, here's a one size fits all solution. So that's why this sort of hierarchical way of looking at this might be something to consider. Yeah, so, but again, I mean, I will reiterate that as far as the technology that Pranav presented today, Avwa, that can work on it pretty much anything. We don't have any constraints on that. It's up to you to specify the fairness. All it does is audit. So that technology is not something that you can take right now and apply it. We've tried it on, for example, housing. We've tried it on some problems related to the census collection. And so we are finding that it can be used. It's quite general purpose in that sense. But yeah, these are great questions. I don't have all the answers. I just have some insights on what we've heard from some of these interviews. Yeah. And again, yeah. But yeah, I will add this, there are some very interesting systems challenges. And I know both Spiros and DK, you guys are interested in this. There are some very interesting systems challenges with getting this to work in sort of a distributed space. And happy to share more and talk more about those
Sure.
with you guys individually.
Thank you.
Any other questions?